Good afternoon, everyone. We are in the very home stretch of our 3 days of wall-to-wall coverage of the Red Hat Summit Ansible Fest 2025 here at the Boston Convention Center. I'm your host, Rebecca Knight, alongside my co-host and analyst, Rob Strechay. Rob, you're a car guy.
I am a car guy.
Most modern vehicles are really defined by software.
Yep. Software-defined vehicles. That's basically what they are at this point. It's crazy.
Indeed. Well, this is going to be a really fun conversation with our next guest.
Yes.
I would like to welcome back to the show Francis Chow, VP and GM in Vehicle Operating System and Edge at Red Hat. Thank you so much for coming back on the show, Francis.
Thank you for having me again, Rebecca and Rob. Good to see you again.
Yes.
So as your title suggests, you lead in-vehicle operating systems and Edge, and Red Hat is obviously making significant strides in these areas. But there are inherent complexities, but also a lot of synergies. Can you talk to our viewers a little bit about how you balance this tension?
Well, I think the way we're looking at our business, in fact, my title reflects a little bit more of how we organize than kind of how we look externally. Emiko OS is a new product that we're building, so I have the typical product responsibility. At the same time, I also have the portfolio responsibility for Edge, as we take advantage of what we've built in the past 20 years, taking what we learned from the IT side, bringing those knowledge and expertise to modernize the OT world. So I have both a portfolio view as well as a product view that's more specific to the automotive world, but that product over time, as you will see later, could be applicable to other industries as well.
Yeah, and I think, again, when you talk about Edge, people are doing AI out at the edge. There's a lot of different complexities and proliferation. What people define as edge is sometimes fluid, but there's retail where they look at their banks or even the end retail spots. Then you have others who look at their factories. We had Ford on. We were talking about their edge is really the manufacturing lines and things like that. Help us understand and highlight kind of the complexities and how you're really addressing those from an edge perspective portfolio.
I think the complexity, there are a couple of dimensions, right? One is every vertical industry have their own language and use cases and ecosystems. So as we get into the edge market, we have to build the right ecosystem with each industry that we choose to kind of work with. And oftentimes what we would like to do is to find innovators in those industries to work with us to co-create solutions with the same open collaboration, open source model, which a lot of industry are seeing the advantage of doing business that way so that we can start those businesses, right? The other complication is the type of systems that we have to support at the edge has a wide range of architectures compared to the more homogeneous architecture that we've seen in the data center world. So we have to enable different types of hardwares, figure out how to work with different ecosystem partners. But in the end, what I think is really exciting is how we can help different industry innovate faster in the open way.
I think one thing that I'm curious about as well is from a perspective of how, because the edge is different. I mean, like when you're talking about a manufacturing line, it's not like I have platform engineering people that are sitting with that there tends to be skills gaps, right?
Yes.
How does Red Hat kind of look at those skills gaps, especially at the edge?
I think there are a couple of things, right? One is we do recognize, right, there's a skills gap, right? So part of what we are doing and plan to do more in the future is how do we make our products easier to consume at the edge, right? You heard about image mode for Rail10. That's one of the ways that we can deploy our operating systems in an easy to consume way. You might have read about the Red Hat Edge Manager.
No.
We are now creating this capability so that OT folks without a lot of IT expertise can have a single pane of glass to help manage the edge devices and applications in one easy-to-use system.
So the automotive industry obviously has very strict safety and reliability constraints and requirements, and rightfully so, because these are people's lives. Achieving certain milestones and certifications are a really big deal. Can you tell our viewers a little bit more about the journey that you went on to reach these kinds of certifications and the technical innovations that are involved?
Good question. And it's been a very long journey for us. We started doing this about 4 years ago when we decided that the automotive industry is on the verge of transforming, as you talked about in the beginning, to software-defined vehicle. But the industry had been practically using software infrastructure that are 20 years old. Now, how do you build advanced applications or AI on a 20-year-old infrastructure? Yes, you can do it, but it's going to be very challenging. So we see that as a potential opportunity for us to kind of bring in modern architecture like Linux, right, to the automotive world. But as you said, right, there are stringent requirements on safety regulations. So we have been on this journey of trying to prove Linux to be functionally safety compliant to the international standard. Now, the challenge of that is the standard was written about 14 years ago. This is the version. A lot of advancement has happened in the software world in the last 14 years. So what we've been trying to do is, okay, how do we meet the objective of the standard, which is, hey, you have a certain risk failure rate that you have to be achieving without having to go through the literal process of the context of how the standard was written 14 years ago, which is microcontroller-based hardware, software that may be 100,000 lines long, and now we're dealing with AI, GPUs, microprocessors, 120 million lines of software. So we're trying to adapt to the new world, but working with our partner Exida to get there with our tailored approach of safety.
When you look at the, I mean, again, the in-car operating system and what it will enable those manufacturers to go and do, and I've talked to some of your customers in this space, and and funny enough, it tends to be Germans. It's like they were always up first with Linux anyway, so it doesn't really surprise me that. What are some of the tangible benefits that they're seeing out of going this direction?
I think the industry is getting to a point that the complexity of the car is very difficult to manage with the old way of designing systems, right, which is more hardware-centric. So what we're trying to bring to the table is it's not just a modern operating system. It's how we can also design vehicles with a more software-centric approach. So the advantage to the car makers is now they could have a platform that instead of building these bespoke systems, every time you have a new model or a new production year, you have to sort of redo a lot of things. You can have a software platform independent of your model years and car model, and then you just add different applications on top depending on the customer's demand and interest. That gives car makers a way more flexible way of implementing software and deploying software, and in fact, updating the car capabilities over the lifetime of the vehicles.
So this is Red Hat. As we know, there is a vast ecosystem of partners, and you work very closely with silicon vendors like Intel, and they are really critical to the success of the in-vehicle operating system. Can you talk a little bit more about how you work with these vendors and how you collaborate and how you then optimize the operating system?
It's definitely a journey. A lot of these silicon vendors, they have their way of managing software, which works really well in the past, which is I design an embedded system, the car goes to production, I pretty much are done with the software, right? But in the new world, as you have seen experience, right, in some of the more advanced car manufacturers, right, you need to upgrade your systems. You can add new functions, just like your phone, over a long period of time, right? And for that to work, you have to have a scalable way to maintain your software platform, right? And this is kind of where our expertise comes in. And so we have to work with the silicon vendors in this space. And hey, how do we work together? One key example was how do we help upstream some of the device drivers, hardware specific, to the mainline Linux kernel, so that everyone can benefit from that standardization, that we can be a part of the ecosystem to help maintain those drivers over a very long period of time. So that when you see bug fixes, hardware upgrades, we would help maintain those consistent operations of those systems.
Do you see that the parts manufacturers and all the modules, because I mean, a car doesn't just come out of one plant. It comes from multiple different plants, multiple different parts manufacturers. Are they leaning into this as well and because they see that, hey, this is coming and we need to get on? You talk about the drivers and stuff like that. It would seem like it's in their benefit that if
it is absolutely in the benefit, Ross. Some of the challenges, right, the car makers are having today, which is one of the motivations for them to change, is, as an example, you would have an application in your car. You would have an application in the website that sits in the cloud. You would have an application in your cell phone, right? These could be the same application, but most companies have 3 different teams designing and maintaining those applications. Practically the same 3 different teams. The reason is they have a different hardware and software operating system for these applications. Now, what we're saying is, hey, if you standardize on Linux, now with safety, you don't need to do that anymore, right? Write your app once, deploy it in the car, in the cloud, in the phone, and it makes the car maker's life a lot easier.
So I think one of the things that I'm interested in as well is, again, this is one of those things that always makes me think, and when we were talking before we got on here around CES, and when I'm wandering through all of the car manufacturers on the floor at CES and seeing what tech they're using behind the scenes, one thing that comes up commonly, and there was one I saw with very large industrial. They make garbage trucks and fire trucks and stuff like that, and they were going towards AI and how AI was used within doing the sorting of actual recycling that would comes out of the bin. They were using computer vision and stuff like that. One of the things that when I was talking to them was about the balance between connection and not connection from that. How does that either help or make your job more difficult from an operating system that's running the car, like a connected car kind of situation?
I think the way we approach this is we can work independent of connectivity. Connectivity definitely give the manufacturer more options on how to operate some of the applications. For example, certain applications that are not timing critical, not safety critical, you can actually run part of that at the edge operating center or in the cloud. Whereas if it's safety critical, timing critical, you have to kind of run everything in the edge, right, or inside the vehicle. So we always been flexible enough. So depending on the applications and the demand, we can cater to both requirements.
So, Francis, you have really painted a picture of how working with Red Hat for car manufacturers has a real value proposition in terms of accelerating innovation and reducing complexity and improving efficiency. But now blow our minds a little here, and what will we feel like as the drivers of these vehicles? What do you see as the most exciting innovations that we will see 5-10 years from now as the actual customers of these vehicles that you're?
I think everyone's been talking about autonomous vehicle, right? Which I think it will happen. It probably will happen further out than people think. Most of that is not because of limitations of technology, but limitations of regulations and legal and ethics concerns. But the technology definitely will kind of get us there. But that's, I think, only part of the excitement, right? I think what's really interesting is what AI combined with edge technology can help change your experience in a vehicle setting. The vehicle could basically look, for example, right, use the driver monitoring system, look at your mood, and then based on your profile and experience, they can determine, hey, you know what, Rob or Rebecca, tonight you probably should have sushi. I'm just going to pre-order it. It's going to be 15 minutes away. That wait time, order ahead of time, drive you there, you do the pickup, done.
Yeah.
It's a completely different experience than, what you could have imagined today.
Oh, wow. I love it.
I think another thing that just popped into my head, because again, car manufacturers also have other edge devices, like we were talking about with manufacturing and how they're doing that. When you look at things like Fleet Manager and how that's going to really change organizations and what kinds of apps they can bring to the edge. Like I was talking to one manufacturer on their manufacturing lines, not in the auto industry. They use computer vision. They're also using robots, and they have to then coordinate all of this. And then they're shipping all this data back to in a central data center because of the AI and the compute power. Are you seeing more power coming towards the edge and in that way, even in same small packages?
Oh, absolutely, right? I think there are a couple mega technology trends that are happening at the same time. AI definitely is moving very fast, but the model is getting smaller and smaller very rapidly. At the same time, the compute power of these edge devices are also especially kind of getting very powerful with Moore's law. Now, the combination of that with the fact that most of the data is generated at the edge, so it sort of makes sense, right, to process the data where it's generated. In fact, what we've seen is some of the analysts are saying that even at the end of this year, more than half of the enterprise managed data will be created and processed at the edge, right? Which is mind-boggling, right, of kind of how fast it's happening.
Francis, thank you so much for coming on theCUBE. Always really a pleasure to have you.
Always a pleasure. Thank you, Rebecca and Rob.
Thank you.
I'm Rebecca Knight for Rob Strechay. Stay tuned for more of theCUBE's live coverage of the Red Hat Summit Ansible Fest 2025. You're watching theCUBE, the leader in enterprise tech news and analysis.